Okay. So the next topic that we have to start is bit manipulation. So let's start with the first one. So it's a simple what we covered in our schools, right? So similarly, we will do it for the OR operator also. Okay. So the XOR operator tells you if both are same, if both bits are same, then it is 0. Okay. The next one is, which is fourth one, left shift operator. Yeah. So this is all about the left shift. We'll just do the right shift and then we'll see like how we can immediately tell the final result also without doing the conversion. Okay. Okay. So the next topic that we have to start is bit manipulation. This is actually a very interesting one. Okay. And somewhere it might seems a little difficult to some people and somewhere it might seems a bit irrelevant, but yeah, this is something which is which we can use in a lot of upcoming sections, and we will be using in a lot of upcoming sections the bit manipulation, the concepts of bit manipulation. Okay. And this is where you do the logic building, how actually bit works. Okay. Internally how bit works. So yeah. Okay. So let's start with bit manipulation. So what are bits basically? Okay. So when we converted a decimal to a binary form, right? So these 0, 1, these are the bits. Okay. These are the smallest unit that how on which a computer operates, right? Bit, byte, and nibble, right? And all those things, right? So these 0, 1, these are called bits. Okay. Now the next unit after bit will be nibble, and then the next unit is byte, and then kilobyte, then megabyte, and then gigabyte, and all those, right? So this is the smallest unit bit. We will see some manipulations on this bit, okay, to achieve some results, okay, and then we will use it in the further sections also, okay. So bit manipulation is basically applying some logical and some arithmetic operations on these bits, okay. So if we say what is bit manipulation, so it's kind of some logical and arithmetic operations, okay, some logical and arithmetic operations, okay, on bits is called the bit manipulation. Okay. Now what we are here to perform. So first thing that we will see that there are multiple operations that we have. Okay. There are multiple operators that we have in the bit manipulation. Okay. So I will just give the name of all the operators first. Okay. So the first operator we have is AND operator. Okay. And the symbol to represent is this. The next bitwise operator is OR. It's simple OR. The symbol to present is this. Okay. The next operator is XOR. Okay. And then there are two other operators. One is called the left shift operator, and the symbol is left shift. Okay. And this is the symbol. And the next one is right shift operator. And this is the symbol for the right shift operator. Okay. So if you sometimes you forget to the left and right shift. So for the left shift, always remember the ending of this will be in the left side. Okay. This arrow, the ending will be on the left side. Okay. This is called the left shift. Okay. So these are the four types of the operator that we have to discuss here. One is AND operator, OR operator, XOR operator, left shift operator, and the right shift operator. Okay. So let's start with it. Okay. So let's start with the first one. So it's a simple what we covered in our schools, right? It's a simple AND operation that we used to perform. Okay. So if we have 0, okay, and 1, okay. So there are two values we can say it's X and Y. This is Z is the result. Okay. So the possible combination could be 0, 1, 0, 0, 1, 1, 1, 0. Okay. Okay. If you're aware about the AND operator, tell me like what is the output for this. So yeah. So for zeros, so in an AND operation, you're saying 0, 0, 1, 0. So basically the AND operation is when we have 0 at any of those, right? Any of the place there is at least 0, then it will be 0. Okay. But to have the set bit as this is 1, right? So both should be 1. Okay. So let's perform bitwise AND of two numbers. Okay. If there is a 10 and you want to perform the bitwise AND with 6, what will be the value here? Can you tell anyone? So to do this, what you have to do, convert it to the binary form for both of those values, and then do this AND operation on each of the bits. Okay. And you will get the result. I will tell you one example, 101. Okay. 01. Consider this is the one. Okay. And you have to perform the AND operation. So 1, 1 is 1 basically, 1, 0 is 0, 1, 0 is 0. Okay. So you will get this one. Okay. So it's simple, similar to this 1, 1, 0, 0, 1, 0, 1, 0, 0. Okay. Similarly, do the conversion and tell me the final value that you have. So similarly, we will do it for the OR operator also. So in the OR operator, basically all these will be 1. Okay. If I draw, when both are 0, then only it will be 0. Okay. When both are 0, then only it will be 0. Otherwise, it will be 1 always. Okay. Can you tell me the OR of 10 and 6? So the OR of this is 14 because we know 1 0 1 0 0 1 1, right? So this will be this will be 1, this will be 1, this will be 1, this will be 0, right? So this is 14. Okay. Anyone having doubt in this? Move on to the XOR operator. Okay. So the XOR operator tells you if both are same, if both bits are same, then it is 0. If both are same, then 0. Otherwise, so can we draw the truth table for this? Yes, we can draw it simply with the logic that I've shared here. If both are same, okay. So if both are same, then it's 0. So both are same here. Both are same in here. Okay. Otherwise, it is 1. So if both are same, then it's 0. Otherwise, it's 1. Can you tell me the XOR of 10 XOR 6? So yeah, this is how we do the XOR operation between two numbers. This XOR will be used a lot of times in the array section. Once we move to the array section, we will do a lot of problems with the XOR. We solve a lot of problems with the XOR. Okay, that we will see. Okay, with this, can you do one thing and tell me what is the value immediately? The value of 10 XOR 10. Right. And if both are same, then we will be having 0 only, right? Correct. So this signifies that if we are doing A XOR A, like the XOR of same number, then it will give you 0. And this property is something which we will use a lot of times in the array section. Okay. Just remember this property because we are using a lot of times in the array section. XOR of two numbers, same numbers will be 0. Okay. Simple. If you are doing the code, then you simply do this thing. I will show you. Okay. You have to simply use the symbol that we have, right? So you have to simply do consider A and B, right?
Right, and XOR.
So you have to just simply do XOR and you have to simply do A XOR B, simple. So you have to simply call give XOR. And we have done for 10 and I think 6, right? So we'll get this 12. Okay, simple. We don't have to do in the code, and right? So I'm just explaining this how you should be knowing the internal function, right? How XOR and actually internally works. Okay. Now, moving on to the next one, that is left shift operator, which is also very useful in the long run for us. Okay. The next one is, which is fourth one, left shift operator. Okay. So how the left shift operator works and what it is. Okay. So basically, when we have any number, right? So the bits to the left by the number, what we tell, right? Okay. Simply, let me tell you, we have written 5. Okay. Left shift by 1. Okay. So this is how much to shift. This will tell how much to shift. Okay. This is telling you to shift by 1. Okay. Shift by 1 means, so what is the binary conversion of this? Binary conversion of 5 is 101. Okay. Now it is asking you to shift to the left by how much time? 1 time. Okay. So shifting it 1 time means what we will do here is, so shifting here means we will add 1 0 in this side. Okay. 1 0 in this side. Okay. So it was 101. So we will add one more 0 in this side. Okay. We will left shift it. Okay. So this becomes, what is this value? This is 2. This is 8, right? So this becomes 10 here. So shifting it left means we will add 1 0 to this side. Okay. This is shifting to the left means. Okay. Now, if someone asks you to shift 5 to the left by 2 bits. So 2 bits means you have 101. Okay. And something like some zeros in here, right? That we don't count. Okay. Now, shifting it by 2 bits to the left means we will shift the number to the left to 2 bits. Okay. We'll just reduce it. Okay. Simple. So this place comes here. This one comes here, right? This one comes here, right? And these 2 places will become 0. And these 2 will be still there, right? Now this is actually 20. Okay. In out in this. So can you do one thing? Shift 5 by 3 bits to the left. Okay. And tell me what is the final value that you will get, the decimal value. Just think about the binary conversion and then do it. So can you do one thing? Can you do 8 and do the bit shift of 2 and tell me the final result, everyone? So basically you can do the binary conversion and just convert it. So you will get 32 here. That's okay. Yeah. So this is all about the left shift. We'll just do the right shift and then we'll see like how we can immediately tell the final result also without doing the conversion. Okay. So this is the right shift. Right shift is denoted by this symbol, this one. Now, can you do the right shift of 5 1 time, then 2 time? Okay. And then the right shift of 8 1 time, and then the right shift of 8 2 times. Can anyone do it all those and then tell the answer? Is it 2? 2, 1, okay. 4, 2, okay. So yeah, right shift, I think you I forgot to tell like how the right shift works. Sorry for that. So basically, so if we have this number, right, 5 for 5, right? Now right shift means adding zeros to this side, okay, and moving it out. Okay, so it means that if you want to do it by 1 bit, okay, so this place will go out of this. Okay, it means this one becomes 0. Okay, this one will come here. Okay, and rest all are already 0, right? So shifting it by 1 bit means this thing. Okay, now if you talk about shifting it by 2 bits, so it means that again 1 bit will be shifted. It means that this 0 will be go out of window again. So it means it will 1 and all zeros here. So this will go out. Okay, this will go out here. Here this will go out, right? Similarly, for 8, if we talk about, so this is 1 0 0, and if you do 2 times shift, so it will come here, one more 0. Okay, so this will come here and all the 0 at the prefix. Okay, basically it will shift 2 times. 2 times means these two will go out of the window in this left side. Okay, so if overall you want to understand, so in the left shift we will add 0 on this right side. In the right shift we will remove the number from the right side, whatever is there. So here we keep on adding, here we keep on removing. Okay, now I think I explained the logic. Now okay, so if you observe here one thing, one thing, so in the left shift we are basically multiplying it by 2. If you see here, we are doing 5. Okay, and we are shifting it by 1 bit. Okay, so for 5, if we shift it by 3 bits, it means we are every time multiplying it by 2. Okay, by 1 bit it becomes 10, by 2 bit it becomes 20, by 3 bit it becomes 40. So left shift is basically whatever number is there, if you left shift it, it means it will be multiplied by 2, while in case of a right shift you are dividing by 2. Okay, if you see at the high level, so right shift is basically divide by 2. Okay, and the left shift is basically multiply by 2. Simple. Okay.